So let's start with this integral here. So let's make some educated guess here. We don't know how to exactly integrate this, but we know that the integral of x to the 11 is x to the 12 over 12 plus c, right? So the best guess, would this equal to this thing inside to the power of 12 over 12 plus c? But we can check by doing the reverse, that is differentiating this thing. So the 12 would go in the front, which cancels with the denominator. That equals to 9 minus 2x to the power of 11. But then because of the chain rule, we have to multiply it by derivative of 9 minus 2x. So that we have an extra negative 2 in the front, which is obviously different from what we have. So in this case, we need an extra negative 2 and this 1 over negative 2 to balance it out, of course. And with this extra factor here, now we can integrate, which leads to this. Then we can simplify from this on. So what exactly this is saying is that we need this part that is actually the derivative of this u with the integral before we can actually do the integration. Otherwise we cannot. What this is saying is that if you call this u, then this part would be your du. And why do we need this substitution? Because we know that the integral of u to the 11 du is actually u to the 12 over 12. So let's start from the beginning. How do we systematically use this substitution to do this integration? So first of all, you let u equals to 9 minus 2x. Then you know du dx is negative 2. Or in other words, du equals to negative 2 dx. So if I look at the original integral, it's missing the negative 2 here. So I have to create this negative 2. And with this, another negative 2 to balance it out. I would then move this negative 2 out because it's just a constant that we don't really care. And move this negative 2 to the back to join with the dx. Like that. So now, after the substitution, it's all in terms of u. So we are integrating with respect to u, but not with respect to x anymore, which gives me this. But because our question is in terms of x, then at the end we just sub it back. U equals to 9 minus 2x. That's the answer. Now for this question, well, obviously it's an integral of e to something, right? And so obviously we'll take that something as u equals to 6x minus 9, and so du dx is 6. In other words, du equals to 6 dx. And so the integral would become e to the power of u and dx here. But we want a du here. So we're creating the 6 to go with the dx and with the 1 over 6 to balance it out. And 6 dx combines into du. Now we're good because the integral of eu is just eu. Think about the reverse again. And finally, we substitute this back into our question here to get our final answer.